Hello everyone. In the previous class we have discussed about the procedural assignments, in which we have discussed blocking assignments. That is the first one. Today we are going to discuss non-blocking assignment. In previous class we have discussed not only the blocking assignment, with also we have discussed with an example how the blocking assignments statements executes. So today we will discuss non-blocking assignment with example, and we'll see the difference between the blocking and non-blocking assignments. So non-blocking assignments are going to allow the scheduling of the assignments without blocking execution of the statement that follow in a sequential block. So in the previous class whatever we have discussed, so those are the blocking statement which blocks the statement within a sequential block. The operator used was is equal to, but here in the non-blocking assignment are the statements, are the assignment statements that are going to be allow the scheduling of assignments without blocking. So here they are the assignment statements operator which is used for non-blocking purpose. So that is going to do without blocking the execution of the statements in a sequential block. So here the operator used for the non-blocking assignment is less than or is equal to. So this together is a non-blocking assignment operator. So remember here, less than or is equal to, it does not perform the relational operation that we have discussed in the previous module in the data flow modeling. So the operator used is same, but the operation is different here. It is a assignment operator. Which kind of assignment operator it is? It is a non-blocking assignment operator. So less than or is equal to sign is used as a non-blocking assignment operator. So here you need to observe that the same symbol is used in relational operator, that is nothing but a less than or equal to operator in a data flow modeling concept. Here the operator less than or is equal to is going to be interpreted as a relational operator in an expression and as an assignment operator in the context of the non-blocking assignment. So in the if it is used in the expression, it is used as a relational operator. It compares the left hand side and right hand side operands, but here in the non-blocking assignment it is used as an non-blocking assignment operator. Here it is going to assign the right hand side value to the left hand side, that is nothing but an assignment. So it is a non-blocking assignment operator. To understand what is non-blocking assignment operator, we are going to do the behavior of a non-blocking statement and its difference. What is the difference between the blocking and non-blocking assignment operators, that we are going to see here. So the same example that we have discussed in the blocking assignment we have considered again here in a non-blocking assignments. So again here reg xyz are register type, then reg a and reg b are register type, but these are the vector 15 down to 0. So each of them are 16-bit. Then a count variable is a integer type. Then your non-blocking assignment operator use will be described in a initial block. So initial is a start of the block, and begin and end are used to group the multiple statements. Now see here, x equal to 0, y equal to 1, z equal to 1. These are the blocking assignment operator again. So previously whatever we have discussed, the is equal to operator is used as a blocking assignment operator. So x is assigned with a value 0, y is assigned with a value 1, z is assigned with a value 1. Then count is assigned with a value 0. reg A is a 16-bit binary number with a value 0, and reg B is assigned with a value of reg A. Now all these are blocking assignment operator. Now see, now the non-blocking assignment operator is used. Reg A of 2 is assigned with a value 1-bit binary 1 after a delay of 15 time units, but the operator used is here less than or is equal to. Less than or is equal to is nothing but a non-blocking assignment operator. Then reg B, it is a part select 15 down to 13. So here x comma y comma z, the concatenation of x y z is assigned to reg B, the 3-bit value after a 10 time units. Then count is equal to count plus 1. It is also non-blocking assignment operator. Now how these are going to execute, that we are going to discuss here. This is a mix of blocking as well as non-blocking assignments. Now in this example, the statement x equal to 0, from x equal to 0 up to reg B equal to reg A, all these are executed sequentially at a time 0, because by default the time is not given here. So by default the time is 0. Then there are 3 non-blocking assignments are present here. 3 non-blocking assignment statements. So at these 3 non-blocking assignments are processed at the same simulation time here. Observe here. First, the reg A of 2 is equal to 0. Sorry, it is equal to 1 is scheduled to execute after 15 time units, because the delay is specified here 15 time units. Then reg B 15 down to 13, concatenation of x y z, is scheduled to execute after 10 time units. Then count is equal to count plus 1 is scheduled to be executed without any delay, that is time is equal to 0 here. So as these are the non-blocking assignments, the simulator schedules a non-blocking assignment statement which are to be executed and continues to the next statement in the block without waiting for the non-blocking statement to complete its execution. So remember here the simulator is going to schedule a non-blocking assignment statements. So all the 3 non-blocking assignment statements, so those are going to execute and continues to the next statement in the block without waiting for the non-blocking statement to complete its execution. The meaning is that the non-blocking assignment statements are executed last in the time step in which they are scheduled, that is after all the blocking assignments in that time step are executed. So in this example what happens is, we have mixed the blocking and non-blocking assignment to just illustration purpose, how they are going to behave. But in practical this is not the correct method. It is recommended not to use blocking and non-blocking assignments in a mixed manner as in this case. Here first 5 or 6 x equal to 0 through reg B equal to reg A, all these are executed at time 0, whereas the next statement reg A of 2 is executed after 15 time units. Then reg B 15 down to 13 will be executed after 10 time units, and count is equal to count plus 1 will be executed at 0th time unit. That means if you compare with the blocking statement, so if these were the blocking statement, what would have happened? That is reg A of 2 would be executed after 15 time minutes, but reg B 15 down to 13 will be executed after 25 time minutes in a blocking assignments. But here it is, as it is a non-blocking assignment, it will not be executed after 25 time minutes. Here it will be executed only after the 10 time minutes. That means the previous statement, even though it is 15 time minutes, it will not wait to complete its execution. Whatever the scheduled time of that particular non-blocking assignment is there, it will execute at its scheduled time. Then count is equal to count plus 1 will be executed at 0th time unit here in the non-blocking assignments. Whereas in the if it would have in the blocking assignment, then after 15 plus 10 25 time minutes it would have executed. But here in the non-blocking assignment, it will execute only at the 0th time unit, because no time delay is specified. That means here non-blocking assignment statements, in whichever order they are written, it does not matter here. Whereas in the blocking assignments, order in which the statements are written, it matters when it is going to be executed. But here, even though the delay time is specified, the order in which they are written, it does not matter. So that's why these are called as non-blocking assignments. So the same thing is explained here in this slide as well as in this slide. So we'll see the application of the non-blocking assignments. So as we have described the behavior of the non-blocking assignments, it is important to understand why they are used in a digital design. So they are used as a method to model several concurrent data transfer that takes place after a common event. So what is the purpose of the non-blocking assignments here? So it is one of the method used to model the several concurrent data transfers. You know what is concurrent? Concurrent data transfer that take place after some common event. After some common event, these are going to be concurrent data transfer can take place. So consider this example where 3 concurrent data transfer take place at the positive edge of the clock pulse. So see here the example, always is a keyword, at the rate. So when you want to generate a clock pulse, a clock is a user defined name here, is the identifier, whereas pose edge is a keyword, POSEDGE. The meaning of this one is positive edge. So positive edge clock pulse. Whenever positive edge clock pulse appears, at symbol is used here. Whenever positive edge of the clock pulse appears, what should happen? That is that you need to write within a always block. So begin end grouping of the multiple statements. Reg 1 using a non-blocking assignment statement, after 1 time unit in1 is assigned to reg 1. Reg 2 is equal to at the rate negative edge of the clock pulse in2 XOR in3, and reg 3 after 1 time unit reg 1 is assigned to reg 3. This is an example. Now we'll see what happens here in the non-blocking assignments. All these are non-blocking assignment. So why it is called as common event? So all the 3 statements are going to be executed only when the positive edge of the clock pulse appears. So here first point, a read operation is performed on each right hand side variable in1, in2 and in3 and reg 1. So observe here, right hand side there are different identifiers are there. in1 in the first statement, in2 and in3 in the second statement, and reg 1 in the third statement. So the read operation is performed on each of the right hand side variable, that is in1, in2, in3 and reg1 at the positive edge of the clock. So whenever the positive edge of the clock, so it's a common event, positive edge of the clock, whenever positive edge of the clock pulse occurs, read operation on the right hand side takes place. So the right hand side expression are evaluated here. So whatever the value is available, those are going to be evaluated and the results are stored internally in the simulator temporarily. Remember here, the right hand side values are, the expressions are going to be evaluated. Then the result, whatever the result appears, that is not going to be assigned directly to the left hand side. Here the results are stored internally in the simulator. So this is going to be a different than the blocking and non-blocking assignments. Here read as well as write operations are performed separately here in the non-blocking assignments. So first the read operation takes place. So the right hand side expressions are evaluated and the results are stored internally in the simulator. Then after the read operation is performed, the write operation to the left hand side variables are scheduled to be executed at the time specified by the intra assignment delay in each assignment. That is scheduled write to reg1 after 1 time unit and reg2 at the negative edge of the clock pulse and reg3 after 1 time unit. So as first it reads the value after evaluating and stores the data internally. Then second step is to write the operation, write operation. So in the write operation, what happens, the left hand side variables, that is reg1, reg2 and reg3, these are the left hand side variables. These are going to be scheduled to be executed at the time specified. So reg1 is scheduled at 1 time unit, reg2 is scheduled after every negative edge of the clock pulse appears, and reg3 is scheduled at again 1 time unit. So these are scheduled to be executed at the specified time unit, that is delay time in each assignment. That is scheduled write to reg1. So reg1 will be written after 1 time unit, reg2 after negative edge of clock pulse and reg3 after 1 time unit. So the write operations are executed at the scheduled time steps. The third point. Here the order in which the write operations are executed is not important. So as I already told you, the whatever the order they are written is not important here, because the internally already the read operation is performed and result is stored internally temporarily. So because the internally stored right hand side expressions values are used here to assign to the left hand side values. Already the evaluated values are available, so those are going to be just assigned to the left hand side variables after the scheduled time delay. That's why whatever the order they are written, first statement, second statement, third statement, the order does not matter here in which order they are written, because they does not execute sequentially. For example, here you can see the reg3. Reg3 is assigned the old value of reg1 that was stored after the read operation. Even if the write operation wrote a new value to reg1 before the write operation of reg3 was executed. We have seen a statement that reg3 is equal to reg1 after 1 time unit. So as the previously itself the reg1 value was calculated, even though the first statement reg1 is assigned with a new value, this old value does not going to change, because already the evaluation of third statement is happened in the read operation, and the value of reg1, the old value, is stored temporarily in the internal of the by the simulator. That's why that value itself will be assigned to the reg3, even though the original reg1 value is if it is changed in the new assignment. So that does not matter. Therefore, the final value of reg1, reg2 and reg3 are not dependent on the order in which the assignments are processed. So to understand the read and write operation further, consider the example here, which is intended to swap the values of register A and B at each positive edge of clock using two concurrent always blocks. So here there are two concurrent blocks are there. First, let us discuss the example, the illustration 1. Here the two concurrent always blocks with a blocking assignment. So in the previous class, whatever we have discussed, the blocking assignment that we are using here. So in the blocking assignment, always at the rate positive edge of the clock pulse, A is assigned with the value of B. Always at the rate positive edge of the clock pulse, B is assigned with A. So this is the first illustration. First, let us discuss the second illustration also. Here, two concurrent always blocks with a non-blocking assignment. So observe here, the non-blocking assignment operator is used here. Instead of is equal to, less than is equal to is used here. That is non-blocking assignment operator. So rest all is same. Always at the rest positive edge of the clock pulse, A with a non-blocking assignment operator B. Then always at the positive edge of the clock pulse, B equal to A. So here in this example, in the first example, in the illustration 1, there is a race condition here. The problem here is nothing but a race condition. So what do you mean by race condition here? So there is a race condition when blocking statements are used. So whenever you are going to use a blocking statement and such kind of expression, there will be a race condition. So either A is equal to B would be executed before B is equal to A, or vice versa. You do not have a sure. If A value is different, B value is different, you may end up getting assigned B is equal to A or A is equal to B. That will not be guaranteed by the simulator here. So it is depending on the simulator implementation here. So therefore what happens here, the value of the register A and B will not be swapped here. You may get A and B value same. So both register will get the same value. Previously A value and B value were different, but they should be swapped here. But that may not take place because of blocking statements, blocking assignments based on the Verilog implementation. Whereas here this non-blocking assignment operator, if you use, it will eliminate the race condition here. So this example illustrates the elimination of the race condition. So that is, at the positive edge of the clock pulse, the values of all the right hand side values are read, and the right hand side expressions are evaluated and stored temporarily in a variable. So during the write operation, the values stored in the temporary variable are assigned to the left hand side variable. That's why separating the read and write operation will ensure that the values of registers A and B are swapped correctly, even though the order in which the write operations are performed. So first what happens here, at the positive edge of the clock pulse, first right hand side expressions are evaluated, that is B in the first statement and A in the second statement. So these are the read operation. After reading the value of B and A, it is going to be stored temporarily in a variable. Temporarily it will store. Then left hand side variable A and B, this is a write operation. The value of the right hand side will be assigned to the left hand side after a specified delay. Here delay is not specified, so it will execute at a positive edge of the clock pulse here. Whenever positive edge of the clock pulse appears, left hand side values are assigned. So what values are assigned? Already the evaluated value in the read operation are assigned to the A and B. That's why the swapping will take place here. So like this, the race condition is eliminated here. The same thing is explained here. So here in this example, implementation of the same example using separate temporary variables. So see here, always at the positive edge of the clock pulse begin. So first read operation will take place. That's why temp A equal to A, temp B equal to B. The value of A and B are stored temporarily in a temporary variable temp A and temp B. So after read operation, write operation will be performed. Temp B is assigned with A and temp A value is assigned with B. So this is what actual implementation of the non-blocking assignment. So for a digital design, use of non-blocking assignments in place of blocking assignment is highly recommended in place wherever the concurrent data transfer takes place after a common event. So as we have seen, a race condition takes place. So in a digital design, in Verilog HDL, you need to use a non-blocking assignment, that is second assignment statements in place of the blocking assignment is recommended here to use the non-blocking assignment. So where it is required, wherever the concurrent data transfer unit take place after a common event. So common event is such as positive edge of the clock pulse or negative edge of the clock pulse appears. What are the different statements that need to be executed? So for such common event, if you are having a multiple statement, so make use of a non-blocking assignments. So in such cases, what happens is blocking assignments can potentially cause a race condition. So in the first illustration we have seen what is race condition. It end up with the wrong results. That's why to eliminate the race condition, make use of the non-blocking assignments. So the non-blocking assignments can be used effectively to model the concurrent data transfer because the final result is not dependent on the order in which the assignments are evaluated. So as in the non-blocking assignment operators, the statements which are written in order, it does not matter. So the operation is performed in two separate parts, read operation first, then the write operation. That's why the order in which they are written, it does not matter to execute matter to the result. That's why a typical application of a non-blocking assignment includes a pipeline modeling and modeling of several mutually exclusive data transfers. Here the requirement of the non-blocking assignment appears. So on the downside, there is a drawback also. Non-blocking assignments can potentially cause a degradation in the simulator performance and increase in memory usage. So as the temporary variables it is going to use, the usage of the memory is more here and it degrades the performance of the simulator. So this is about the non-blocking assignments. Thank you for watching the video.